Hello everyone, this is Dennis, and you are on the Electro channel. Today we will make a very bright strobe. The strobe circuit looks like this. Its basis is the NE555 chip. It creates pulses of different frequencies. The frequency can be changed using a 1 megohm variable resistor R3. Signals from the microcircuit are fed to transistor Q1. Under the action of pulses, it opens and closes by supplying current to the LEDs. In my strobe, I use small SMD LEDs marked 2835. Their operating voltage is 9 volts. There is only a 3.6 ohm limiting resistor in front of them, since the supply voltage of the circuit is much higher. The current consumed by the circuit is about 200 milliamps. In flashing mode, this resistor is enough. But if the LEDs burn from 12 volts through this resistor constantly, without a strobe, then they will naturally burn out. If you accidentally reverse the polarity when connecting power to the circuit, the microcircuit will immediately burn out. Therefore, I introduced a protective diode D2 into the circuit, but he is not required. The circuit will work without it. If you do not need it, then plus can be applied directly to the 8th output of the microcircuit. I'll take the LEDs from the burnt-out LED light bulb. LEDs marked 2835 are installed here. Their voltage is 9 volts. To unsolder them from the plate on which they are installed, a high temperature is needed. This is where the homemade heater that I showed in one of the previous videos comes in handy. The plate heats up quickly, the LEDs are soldered, I remove them to the side with tweezers. Everything is done very easily. Then all soldered LEDs must be checked. To do this, I use the LED tester that I showed in the last video. Excellent LEDs are intact. So that the LEDs do not move when soldering, they must be glued to electrical tape, and then connect with thin wires. You need to solder very quickly so that the LED does not turn into plastic porridge. Then the LEDs need to be checked again, so that the LEDs do not fall off the board. I poured sealant under them. The dimensions of the stroboscope turned out to be small. The transistor does not heat up the radiator it does not require. The transistor here is taken with a large flow margin. Therefore, if you have another, smaller but weaker, then you can put it on. Now everything is ready, and you can turn it on to see what happened. Flashing. But on video, the flashes look weak. In fact, they are very blind even in daylight. Now the lowest frequency. Turning the knob will raise it. The blinking frequency is high, but not so much that it seems that the LEDs are constantly on. Despite the fact that LEDs have a lot of brightness, like from an LED light bulb, it will not work here. The brightness decreases due to the fact that the LEDs are not constantly on. If desired, the brightness can be increased by reducing the resistance of the current limiting resistor. But then the LEDs will get very hot and may burn out. Therefore, the best way to increase the brightness is to add new LEDs. That's all for today. Put likes. Subscribe to my channel if you haven't already. Ask questions in the comments if something is not clear to someone, and bye-bye.